Okay, so now we're going to talk about exponents. Make sure that we understand this brand new concept that involves multiplication, but it is not the same as what we talked about when we were doing multiplication of integers. First, let us recall that when we speak of multiplication, what we're talking about is the notation we use when we are adding the same number repeatedly, when we're doing the same thing over and over, but it's adding. So for the example that we have right here, we've got this group of sevens, and you can see writing out this addition in this string, it takes up a lot of space. It's long, and it's tedious to write all of that out. Furthermore, we see that there are eight different copies of the seven. And so, what we said about multiplication was multiplication allows us to write this string of sevens to represent what that means, but to write it in a shorter, more concise notation, which of course we have down here 8 times 7. The 8 obviously saying here's how many copies we have, and 7 being what we have the copies of, the number that's being added repeatedly. So, of course, this is a lot more concise, a lot more comfortable and easier to write. I mean, just try and think if we're writing things out with the and using the addition format, just imagine if we had something like 253 times 127. Can you imagine trying to write out the addition statement for this? That's a real pain in the neck. So, of course, using this notation is math's way of being able to say we can actually shorten this up, make it a lot more concise, a lot more convenient to write and to read. And therefore, that is the purpose of multiplication. And of course, now we can take a look and see some examples of that. Of course, we said this in class 3 times 5 means I got three copies of 5. So I got the 5, 5, and 5. I got those three fives, I'm adding them together. We also said you could read it backwards. 5 times 3, in which case I got 5 copies of 3. So I could have 1, 2, 3, 4, 5. And now we're adding all of these together. And of course, we get the exact same answer as if we just had the three copies of 5. 6 times 10 can tell me I've got 6 copies of 10. 1, 2, 3, 4, 5, 6, and I'm adding them all together. It could say I got 10 copies of 6, and I'm adding all those together. But that's what multiplication means. So please commit this to memory. It is repeated addition. Now let's talk about exponents on the other hand. Exponents, this is the shorthand we're going to use when we're trying to show not repeated addition, but repeated multiplication. So I have the 6 here. I got this 3 that's raised to the right corner of the number. And that 3 is telling me I want 3 copies of 6, but I don't want you to add them together. I want you to multiply them together. So this would then be expressed as 6 times 6 times 6. I have the 4 with this 5, this little 5 to the raised right-hand corner means give me 5 copies of 4, and again, not added together, but multiplied together. So 1, 2, 3, 4, 5, and I'm multiplying them all. And lastly, I've got the 8, and then I've got the 2, and the 2 telling me I got 2 copies of 8, 1, 2, and I'm going to multiply those together. So exponents means repeated multiplication, where multiplication means repeated addition. All right? Let's talk about the parts of the exponential expression. The number, this larger number, and the number that we're going to be repeatedly multiplying is called the base. All right. So that's 6 in this expression. That is the base. The 3, you're probably familiar with these terms. It's the exponent or the power. And the purpose of the exponent or the power is to tell us how many copies of the base we'll have to multiply together. So again, in this case, I see I got the base of 6. The exponent or power is 3. That means give me 3 copies of 6 and then multiply them all together. Okay? Let's go further. You know how to say these. You probably have said this plenty of times. So the way we would pronounce this, of course, is 6, the base, raised to the third power. All right. 2 to the seventh power. 8 to the fifth power. And once again, That power you're raising to is indicating how many copies of the base we're going to actually multiply together. So if I was going to expand 6 to the third power out before I multiply it, I would write 6 times 6 times 6 and then do the multiplication. 6 times 6 is 36. All right, so that'd be 36 times 6, and that'll come out to be 216. If I'm doing 2 to the seventh power, 1, 2, 3, 4, 5, 6, 7. And we're going to multiply these all together. All right. So I got 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32, times another 2 is 64, times the final 2 is 128. Then that must be what this is. And last but not least, of course, we can do the same thing with 8 to the fifth power and multiply that all out as well. Okay. Now, we pronounce these to the third power and to the fourth power to the fifth power, but you also know that there are two terms that we use for special exponents. 6 to the third power is actually one of those special exponents, and you probably remember these two terms. They were squared and cubed. All right. You may have heard those terms and thought that people were just calling it that just to be calling it, not understanding the why. And again, I'm going to emphasize to you, find out the why. Always ask for that because math, again, is rooted in logic. There's a reason for everything. So take a look at this diagram. We have a square here, and we know a square, all the sides are the same. So I've got a 9 by 9 square. If I want to know the area of that square, then it means take the two dimensions, 9 and 9, and multiply them together. And 9 times 9 can be rewritten as 9 to the second power. And of course, since it creates a square, we then say it is 9 squared. All right, that's where that comes from. All right. Also, we can look at it, a square is a two-dimensional figure, meaning it has a length and a width. And notice that the exponent is also 2. All right. So again, it's a number being multiplied times itself, which is just like the sides of a square. So whenever I see a number to the second power, I can think of that as the dimensions of a square, and therefore we call it 9 squared. Now, you probably are way ahead of me now and saying, oh, well, then if it's to the third power, that would be the third dimension, right? In this case, I have a length, I got a width, and now I got a height. And if I wanted to find the volume of this cube, I would take the three dimensions and multiply them together. 9 times 9 times 9, the length times the width times the height. But since it's the same number being repeatedly multiplied, I could just rewrite that as 9 to the third power. And the figure it forms is a cube. So therefore, 9 to the third power, we say 9 cubed. All right. That's the only reason. There's no more scientific reason than that. It's just that we're raising it to the third power, and it's just like finding the volume of a cube. So therefore, 9 cubed. It also explains why if we have something like 9 to the fourth power, there was no special term for that. I don't know what a cube or a square in 4 dimensions is called. I don't even know what that looks like. Do you? So we don't have any special word for that. So it's just 9 to the fourth power and 9 to the fifth power. It wasn't that somebody just arbitrarily decided to the second power and to the third power would be squared and cubed, respectively. It was the shapes that they corresponded to that led to those names. So I just wanted to share that with you so you understand there is again a reason these things happen the way they do. Now, in terms of our practice right here, very simple. And this, by the way, is the way I want you to write out your homework as well. You'll see it done this way in the examples in the book for the homework assignment I'm going to give to you. First thing I want you to do is show me that you understand what this means. All right. So when I see 2 to the fifth power, I know it means I've got 5 copies of 2. We write that out first. Then you're going to multiply it. 2 times 2, okay, that's 4 times 2 is 8, times 2 is 16, times 2 is 32. This is 32. Here I've got 9 squared. All right, we've seen this guy already. So 9 squared, that's going to be 9 times 9, which is plain old 81. 4 cubed, or to the third power, is 4 times 4 times 4. And that's 4 times 4 is 16 times 4 is 64. And last but not least, we got 3 to the fourth power. That means give me 4 copies of 3 being all multiplied together. And now let's multiply. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So this is how we would expand it out and then multiply to get our final product. And when you're doing your homework, I want you to expand it out first, like you see that I've done here, and then go ahead and do the multiplication. Don't just type this into a calculator or just start figuring this out in your head, however you're going to do that. Make sure you expand it out first and then go ahead and do the multiplication. And with that, folks, that is the assignment that I want you to be working on. And so you'll just practice those things. The assignment, of course, will be posted on Canvas. So just make sure that you're practicing those things, and I will see you in class. That'll be on the 21st. All right, everybody, take care now.